All right, so let's move on to the next item on the agenda, and that item is or are classes. Right. Now, what are classes? Now, when we were discussing functions, right, we said the benefit of having functions in our code is that we can have more like a modular structure of our code. Like for example, you're designing a car, you have some portions or parts of the car that deal with the engine, right, or the mechanical aspect, some functionalities that deal with the electrical system, some functionalities, let's say, that deal with the chassis of the car, and so on and so forth, right. So you can have those different blocks and then you can combine together to make a car, right. So that was the idea that we discussed behind functions, that we can have a bit of more modular structure of our code. Another reason why do we like to have functions is that if we want to have a set of or some specific lines of code or that does something particular and we want to do it over and over again in our code, right, in place of repeating those lines of codes over and over again, we can just have a function out of those lines of code, right, and then we can just call that function to do something that is desired, and then that was just going to have a more compact code. Okay, now what are classes? Classes just extends the idea of functions, and these are linked to or they came into existence when we started developing those object oriented programming languages, right. And what is the idea behind classes? In classes we have even a better modular structure of the code. That is the the basic idea why do we want to have classes, because it's possible that we have different aspects of the code that do not need any interlinkage. For example, let's say you have a class of persons, right. Now persons will have certain attributes, like for example you would have, let's say, the name of the person, the age of the person, right, let's say what is the education of the person, and so on and so forth. So you have certain attributes that are specific to persons. Let's say you have a section of the code that deals with cars, right. Now for the cars you would have other attributes, right, like for example let's say what is the weight of the car, right, what is the horsepower of the car, right. You would not need to have the horsepower attribute for the person, right, although someone was telling me that a person is like 1.2 times the horsepower. I'm not sure if that is correct, right. You better check, right. You can use your Google skills, but that means I would be really stronger than a horse, right. I mean, I'm a bit stronger than a horse, but I'm pretty sure if a horse kicks me I will not have a good experience, right. But you get my point, right. So if you have a section of the code that deals with persons, so you have some attributes that are specific to the persons, right. You do not need information about the cars in that particular section of the code, right. So because the person would not need information about the horsepower, right, of the person, right. Similarly for the cars, there are certain we do not need attributes that are particular to the car that that are for the persons to be shared with the car, right. So you can have different classes that deals with different things. Those classes can have their data, like for example in the case of the class person you can have the data, let's say age, name, etc., right. In the case of the car you can have the data, for example let's say make and model of the car, right. You can have the data, for example the horsepower of the car, and so on and so forth. And then you can have functions that operate on these data. So if you have a function that deals with the age of the person or the name of the person, you do not need that function to be accessible or to be accessed from the car data, right. So it does not need access to the car data, it does not need access to the functionality that is specific to the car. Similarly, you can have functions that are specific to the car in the class of cars. So that way we can have a collection of data and functions that operate on that data in object oriented programming. Okay, so this is the basic of this object oriented programming. Okay, so I have a quick introduction of classes. Now how do we define classes? To define classes we use the keyword class. So this is the keyword class that will tell me that I'm going to define certain class, right? Let's say I define a class named person. Yeah, okay. Now, when I start a class, we have a certain function which is specific to classes. What does that function do? When I say, okay, give me a variable of type a certain class, right? Let's suppose when I define, let's say, a person class that has name and age, right? And then I have some functions that operate on these particular, sets of variables. And then I say, okay, give me, person A, person B, person C with name this one, this one, this one, right? So then how am I going to create those different variables, right? Those variables, we call them objects. How am I going to create those different objects? Those objects have a certain class type. So how am I going to create those different objects, right? So to create those different objects, we have a special function inside the classes or for the classes that we call the constructor function, right? That we call the constructor function. And the constructor function, I mean, uses the same keyword def to define the function, but it has a special name. You have double underscores, right? And then you have init, and then you have double underscores, right? And then you have you start the parentheses brackets. And to show that this function is a member function for this particular class, you use the keyword self. It just tells you that this is linked to this class, right? And then you have, this colon, as you do in normal function definition. And then inside you can do whatever you want, right? You can decide how you want the class to be constructed, right? For example, you can say a variable age, right, and a variable name, right? And you want to say the name is Ahmed and the age is, let's say, 30 years. Yeah. But to tell that these variables are indeed the member data for the class, yeah, you need to use the keyword self again. So you need to tell self dot name is equal to Ahmed and self dot age equals to 30. Yeah. And then I can have some member functions for the class. I can say df, it says print underscore data, and again I have self to show that this is a member function, and I say print the person is of name. I say self dot name, and I say and age. I say self dot age, right? And sometimes, if you want to return this function to return something, you can also do that. Sometimes you want to change the values of the member variables as well. For example, I want to say df increment age, right? So again, it says self, right? And this, when I will call this function, it will just increment the age of the person by 1, which is the same as self dot age equal to self dot age plus 1. So it will just increment the age of the person. Now if I want something else to be done inside the function, I can do that. For example, I can say print the new age of the person is self dot age, right? And yeah, that's it. And I say, let's say this is a random statement. Now when I'll run this code, right, this section of the code deals with the definition of the class, right? You can also think of classes as user defined data types that also have functions that operate on those data, right? Okay. Now this section of code defines the class person, and this line of code is something that is outside that definition. So when I run this code, only this line is going to be printed. This section, like we had in the case of the function definition, it will run and this will just stay somewhere in the memory of the computer, that okay, this is the blueprint of the class that I can create. You can think of this definition as like sort of a blueprint. Like for example, you have blueprints of buildings, right? So you know what design of the building is, right? You have blueprints of the car to know like what kind of car you're going to build, right? And so on and so forth. Okay. Now, if I want to create objects or variables of type class, so how to do that? Let's say I say person A equals, I just call the name of the class and then I use these parentheses, right? I say person B equals person, again this guy. Now you have two variables of type class, we call these variables objects. So you have two objects of type person, but each one of those persons, person A and person B, will have the member variables that have the same value. They are different, but their member variables have the same value, right? For example, I can say person A dot print underscore data, and it's going to complain. Oh, it didn't complain, but just tells this is like a method, right? The function. I need to use the parenthesis. So this person is of name Ahmed and age 30, right? Similarly, if I had person B dot print data, so the person is of name Ahmed and age 30. They both have same values of the member variables, but they are different objects. Okay. Now let's say if you want that in place of having predefined values of the variables of the member variables of the class, you want to pass on some values so that the member variables get those values, right, and assume those values, right. And for that you need to just modify this piece of code, for example, a bit more. You say class person, let me call it person X, right, and then while creating, for instance, you want the member variables to assume certain values that you have passed on to the class, right. So you can have, let's say, an input argument to the constructor which says input underscore name, and you have another one input underscore age, and you say self dot name is input underscore name and self dot age is input underscore age. So now when you run this, so you say you create person A and B, but since the name of the class is now person X, right. So now if you run this without any arguments over here, it's going to complain because it expects two arguments for this constructor. One of them is the name argument and the other one is the age argument. Let's say if I run this without anything, so see it's complaining, saying missing two required positional arguments, input underscore name and input underscore age. So I can say, for example, name is, let's say, Ahmad, right, age I say it's 15, and for person B, let's say the name is Omar and age is 20, right. So now if I run this, it's going to be fine, right. And then I say person A dot print underscore data, and now you can see, person A is of name Ahmad and age 15, but person B is of name Omar and age 20. So this way you can pass on some values to the constructor of the class so as to change the member data of the class. Does that make sense? All good? Any questions? Yeah, good. Okay. Just to add one comment, similar to functions, we can also have default values of these arguments. For example, earlier when I did not specify an argument, it complained, right. Now let's say I want to have some default values. Let's say the default values are Ahmed and input age equal to 30. So these are default values. So if I do not specify any input when I create an object, for example here I say person C equals person X without any input, so it will just take on those default values. Say person dot say the name, the person is of name Ahmed and age 30. Clear? Yes. Mm-hmm. What do you mean? Yeah. Okay. That is linked to inheritance, but that is beyond the scope of this course, right? What's your name? Ali, right? So what Ali is referring to, let's suppose you create a class of type persons, right? And then let's say some persons may be students as well, right? Then you want to create a class of type students, right? Now both person and students are humans, right? And they are persons, right? So student is going to have some attributes that a person has, like for example is going to have the name and age, right? But then student may have something extra, like for example CGPA, right? The courses that it is taking or something. So what we can do, we can create a class named student, but it inherits from the class person, right? And it takes on the attributes that the class person has, but it can also add more attributes. Yeah, this is what we call inheritance in object oriented programming, but that is beyond the scope of this course. Clear? Yeah, good. Moving on. Excuse me. Now one more interesting thing about Python is that you can, when you pass on the arguments, right, and you do not really know on what order the arguments appear in the definition, right. So you can just write the name of the argument which you have over here, for example, right, and then you can say equal to, and then you can have the argument value, right. There are two ways you can pass on the arguments to the to a function in Python. One is based upon their position. For example, in here the first argument is Ahmed, so for that reason this guy will take the value Ahmed, and the second argument is 15. For that reason this guy will take the value 15. So that is one way. Another way is to specifically write the name of the arguments, and then you have the equal to and then the value. This way, if you want to, let's say, switch the order, you don't need to have the correct position. Even if you switch the order, it should run fine. For example, here when I say person X, sorry, not person X, person C dot print underscore data, you can see, it have the correct values of the arguments, even if they appeared in a different order. But since you fix that situation by specifying the name of the argument. Clear? Any further questions? All good? Okay. So this way, this is how we conclude the